Let's solve this calculus problem step by step. The question asks us to differentiate the function f of x equals 3 raised to the inverse sine of x. Let's break this down using a step-by-step approach. We'll use a two-column format to show both the mathematical steps and their explanations. First, let's identify what we're dealing with. This is a composite function where we have 3 raised to a power, and that power is itself the inverse sine of x. We'll need to use the chain rule here. The chain rule tells us that when differentiating an exponential function a to the u, we get a to the u times the natural log of times the derivative of u. Applying this to our problem, we get 3 to the inverse sine of x times the natural log of 3 times the derivative of inverse sine of x. Now we need to recall that the derivative of inverse sine of x is 1 over the square root of 1 minus x squared. Substituting this in, we get our final answer, 3 to the inverse sine of x times natural log of 3 all over the square root of 1 minus x squared. Let's verify our answer makes sense. The domain of this derivative will be the same as the domain of inverse sine, which is -1 to +1. Also, notice that as x approaches either 1 or -1, our denominator approaches 0, which means the derivative grows very large at these points, just as we would expect. And that completes our solution. Remember the key steps. Identify the composite function, apply the chain rule, and recall the derivative of inverse sine.